What is the time? Is it noon yet? So should I say good afternoon, everybody? Oh, 11:30, so sorry. Okay. Good morning, everybody. My name is Isaiah Page. We'll be presenting our Capstone Senior Design Project. We like to call our team name Codec, but we're really trying to provide a highly secure software platform that supports smart locks. So this is going to be the breakdown of what we'll go through, how we got motivated for our project, and then how we decided to break down and all the iterations that we went through to get where we are today. So my name is Isaiah Page. I'm an electrical engineering major, and I'm the project lead.
My name is Marcel Rivera. I'm a computer engineering major, and I'm the software lead.
My name is Ray Rex. I'm a computer engineering major, and I'm the hardware lead. So our goal with Codec was to create.
So our goal with Codec was to create a smart lock service that aimed to solve the current problems that exist in the industry, which is namely the lack of secure security features. So our main design objectives with our project was to make smart lock technology safer and more secure, while also making smart lock security into a service that we could then apply to numerous devices that already exist on the market. In order to do this, we proposed the idea of introducing a level of encryption between the database and the legal phone, while also using a mobile application that would act as a system bus that connects our mobile devices to the legal phone.
So the market right now is flooded with a ton of different products out there because smart locks in this new age of internet technology has been oversaturated, and so we see a lot of products like the August lock all the way to the left, which is very secure but also very expensive, going on the range of $200 up to like $300 for just single components that need to be integrated together. And then in the middle you'll see a lower end lock that integrates lower encryption, so lower security, but it's also more cost reliable, but it's not as reliable to consumers, and it leaves them open to certain security breaches. So the goal for our product was to have a low-cost system that can also provide a higher level of security than what's on the market.
So smart lock technology is now entering mainstream usage. More and more people are turning to it, and it's becoming one part of the Internet of Things. There's a lack of secure and safe features in place on a lot of these devices on the market. And this affects anyone from homeowners, businesses, government facilities, and by improving upon the security, we can provide them all with a better service and products. So when creating our project, we really focus on our marketing requirements and engineering requirements, because we knew that if we worked on these, we would provide the best product that we could. So we wanted high performance, very robust security, connectivity with Bluetooth and Wi-Fi. We want to keep our cost of production as low as possible, and we want it to be compatible with current devices already existing on the market. So in terms of our market requirements, we want it to be easy to use. We want to be compatible with things that people already would have. We want security to be very high, and so people would feel safe when they use our product. We want it to be reliable, and we want it to be economic and eventually lower the cost of what devices already exist on the market.
Here we can see a general description of how our system works. We have two mobile devices, which are the home device and then the guest device, communicating through a mobile Android application that we have developed. This application then connects to the Beagle phone, which communicates to and from a database. This is where the encryption process will happen. After this encryption process has occurred, then the Beagle phone sends via Wi-Fi the already encrypted key to the guest device. Once the guest device receives this encrypted key on the application, then the last step is just using this key to unlock the smart lock using near-field communication. The related theory that we've used in this project is been the MD5 hashing algorithm. This algorithm is used to protect users' password integrity, since we cannot store passwords in plain text on a database. We're also using the EECE411 encryption algorithm, which produces a 512B cipher, decreasing memory and processor power, which is what we need on a system like this. We also have the linked list concept. The data that's organized in our tables is structured following this linked list concept, in which all of the information from one user is linked to the user's ID number. And the pseudo-random generator uses math formulas to generate sequence of random numbers. These random numbers are used on the encryption process, generating a unique key for each user.
So this is a hardware design that we use to simulate a smart lock, because buying one and then reverse engineering it would have been too much money. So our main components are the NFC module and our LED circuit, which are both powered by an Arduino Uno. So to emulate NFC, we use the PN532 NFC RFID module. Some features of it include an SMD toggle switch, which lets us change the working interface from UART to I2C, which is what we use. It has up to 7 centimeters of reading distance to read our NFC tags, and it's 43 by 41 by 4 millimeters in size. And in order to connect it to the Arduino, we use the 2, 3, 4, 5 ground and 5 pin and 5 volt pin. This circuit here was used to emulate the opening and closing of the smart lock. So when the user is granted access, it would light up signifying that the lock would be open. We built it using a red LED and a 220 ohm resistor, and to connect it to the Arduino, we use a D13 and ground pins. And this is the BeagleBone Blue, which was our main microcontroller that holds our database and connects to our server automatically upon startup. We used Cloud9 IDE, which is where we did all our software working.
Our software solution that we're proposing. So we have instance running on Amazon Web Services, which holds our server in which our tables are located. As mentioned before, the BeagleBone would automatically connect to the database at power on. That's how it's been coded. Also, a query has been coded into the BeagleBone to allow the board itself to put information to a current database to the user's ID number. RESTful services have been put in place on the server end to allow communication between the server and the application. These RESTful services allow the server to submit the package, which in this case will be the encrypted key, to the under application via Wi-Fi. The encryption process happens between the database and the BeagleBone. In here, unique random key will be generated for each user. After this key is generated, it runs through the EECE411 encryption algorithm. And once this key is created, it's stored on the database and it is ready to send to the user. For the application, here's how our application looks like. The application connects to the database through the RESTful services and pulls the user information from the authentication table. After the user has input their credentials, a validate function is run. After the user is verified, user can download the encrypted key to the phone. Users can also add their information to the database. So, as you can see in the first picture, after our user inputs their information, it updates automatically to the database. Here we have a demonstration video of how the full system works.
Thank you. Sorry for the technical difficulties, but we'll come back to it. Yeah. So we'll show the video at the end, time permitted. So in the completion of this project, we learned a lot since we were working in environments that are not provided to us in school. For me, I know especially I was working in Android Studio, and I was working a lot with Python, which is a new coding language for myself. And we went through a lot of different iterations through this project, especially with the application. I know Marcy was working a lot on the server end, the database end, she had to go through a lot of different iterations because, especially through different Wi-Fi connections between a home connection and JasperNet, we were getting blocked through certain firewalls. So we had to overcome certain obstacles when developing this project. We were unable to get certain functionalities working in this project. We were able to connect with a phone to the database and register a user and then have NFC uploaded to the device. However, some of the functionality that we want to provide in the future is having a select home device be able to assign a guest to the server, as well as develop our own lock enclosure to complete, the tail end of the hardware for this project. So we did have to go through a lot of iterations, as I was saying, specifically for the application. Since it was my first time working with Android Studio, I had accidentally had the registered users putting their information on the device instead of to the database. So Marcia was able to help me in pushing user information from the application to the databases. And for the encryption and with the BeagleBone, we were going to initially use Bluetooth, but unfortunately that type of connection wasn't working, so we switched over to Wi-Fi. And then later on in the semester, we also got the integration from pushing information from the user's device through the application to the server, and then back again to provide, the encrypted passwords. And we made sure that everything was secure. And unfortunately, you couldn't see it in the video, but you don't see any of the user's password information on the servers. Everything is encrypted, and security is upheld throughout. So this is some of the costs for this type of device. A lot of the components came from the BeagleBone and the Arduino especially, but for the overall price of this kind of product, it was like roughly around $150. So including some of the devices that we had already, so we didn't have to spend a lot of money, but this shows us that we can incorporate a higher level of encryption without having to jack the price up to $200, $300 and still provide a secure, affordable solution to consumers. And so throughout this entire process, we were inspired to try and provide a higher level of security and adhere to higher level of ethics through our project that we're not really seeing in the market currently. So ethics and codes and standards were an important thing to uphold through our project, especially with Wi-Fi and encryption protocols. And then these are something we definitely upheld to the IEEE standards and ethics. And these are our references. Let's see if we can get that video working. Are there any questions in the meantime?
Talking about physical line
Yeah.
or the software line.
So the software side is the encryption and database, but in the hardware end is an NFC lock, which would either control a motor or be a magnetically coupled lock.
These things could buy at Home Depot.
Mhm.
Yeah, I mean, probably not Home Depot, but it would be a lot more money than trying to build this one.
Just a question on that, the choice of processor, why did they do that?
So the BeagleBone comes already with the integrated IDE, which is Cloud9. Also, we we use a Raspberry Pi, would have to integrate something like a monitor, a keyboard, and a mouse. When we be able to set up, it's really simple, just plug into the laptop, and from there it's go.
Hello ladies and gentlemen, welcome to our demonstration video of our project. Here is an overview of the components in our project. Our BeagleBone, Arduino, and NFC module, as well as our application. Here is our BeagleBone, which is responsible for connecting our users to our servers as well as keep their information private through encryption protocols. Once you are ready to use the NFC, you can tap your device on the red NFC reader and the Arduino will read the user key and open the lock. Here we will be logging into our application. Once you have successfully logged in, you will be able to connect to the server, which will download your key, and then you can start using NFC to interface with your lock. Here on the server side we can see the account we have just logged in with. The customer's password is always encrypted to ensure the utmost privacy. Thank you for your time today.
Thank you.